All right, so our last little topic, we're gonna be looking at some graphs. We've been doing some graphs and then using those graphs to find solutions. So today we want to know what we can find out from our graphs. I think we can wrap up those conversations so we can get through our notes, please. So we want to be able to look at functions, mainly like two functions, and be able to figure out that relationship when it comes to graphs and what it means when it comes to solving all of those little guys, right? All right. In your guys' textbook, there are these little sections that have these little math notes, and you always know it's the math notes when it has that nice little magnifying glass. And it kind of goes, there was three main topics when it came to 4.2, our section. One of them had to do with inequalities of absolute values. So if you kind of go through, it kind of talks about, you know, how to set those problems up. Biggest thing to remember, like if you look at that example right here, in order to solve that problem, you want to make sure that you get that absolute value all by itself. So sometimes we'll get some crazy problems. We'll kind of walk through a little bit of an example. But we want to make sure that we are only at our absolute values, the only thing left on that one side of the inequality. And then once we have it to where it's only the absolute value on the one side, then we're going to set it up to where it's just the way that it's written. And then the other one is flipping the sign and flipping the inequality, right? And then going through and solving it that way, right? So, I don't know, you want to come up with a crazy problem to walk through? So let's say we had 2, and then the absolute value of x plus 7 minus 3 is greater than or equal to 13. And we know by definition, absolute value is what?
Distance, like distance from 0.
Yep, absolutely. Good job. Distance from 0, right? So, and we know that distance has to be positive. So when you take the absolute value of something, it's positive. But technically on our problem up there, our x could be negative. So your x's can be negative. It's just absolute values cannot be negative, right? All right. So in order to solve this, we're going to start off like it was any other equation. So what do we want to do first? Add 3 to both sides. Yep. And we still have our 2. Oh, I don't want that color. Well, 2. Then our absolute value of x plus 7 greater than or equal to 16. All right? Divide by 2. Divide both sides by 2. So now I get the absolute value of x plus 7 is less than or equal to 8. All right? So now I have my absolute value all by itself. So now I can create those two inequalities, right? So I'm going to leave it just the way that it is. So x plus 7 is greater than or equal to 8. And then my second one, I'm going to flip the sign. And I'm going to flip the inequality. And then I'm going to flip the sign. So what do I get? X is greater than or equal to 1. And x is less than or equal to negative 15. Then I get those two answers.
Wait, so
Say it.
how did you, I'm just trying to figure out the step to get x is greater than or equal to 0. Did you just, I mean, what?
Subtracted 7 from both sides.
Say this function in equation.
Pardon me?
So you're just like finishing the equation?
Yep, yep. Yep, once you get rid of those absolute symbols, those little bars, then you can, it's just like a regular equation. Yes.
So to get rid of those, it's always going to be you flip the inequality and then change the sign.
Yep, yep, flip the inequality, and then you're gonna, one stays whatever it was, and then we, yep, switch that one to a negative. Yep, if this would have been a -8, then you would still have the -8 and the +8. Yep, yep, good job. All right. One of the other big components under the math notes had to do with graphing those inequalities. When we have, right? So this is when it comes to an inequality. An inequality, you're always going to do that shading when they want you to graph it and look for those solutions. So through our numerous years of mathematics, we've gotten to where we can graph equations, right? We can even use decimals to graph some of our equations. So then, and honestly, I think a lot of times the easiest way to do it is to like test a point, right? Origin, as long as your origin is not part of your graph, as part of your function, I always test 0, 0. 0, 0 is always the easiest one to do, right? Especially if it's multiplying, it's going away. If you're adding or subtracting, it's not changing anything. So I always like to try to test that point 0, 0, right? If it comes up that it's true, when you test that point, that means you're shading. Shading means that that's the solution, the part that you want. So when we tested 0, 0, it came out to be true. So then you shade wherever it would have been 0, 0, right? When it came to quadratics, you're either going to be like, here's your quadratic. You're either going to be on the inside of the quadratic or you're going to be on the outside of the quadratic, right? On the lines, you're going to be on one side of the line or the other side of the line. You guys good with those problems? You can bring colored pencils if you want, right? And then the third one had to do with like, how are you going to find those solutions, right? So when we have those systems, we're looking for kind of like where they intersect, right? So there was a couple different ways you can do these. If you have these two equations, you can either, what was one way you could solve this? You could, starts with a G. You could graph them, right? And when you graph, you're looking for, what are you looking for?
Intersection.
Yep, look for where they intersect. Right? So if we jump over to decimals, and what did I had? Y equals x. Oops, I gotta make that a little smaller, sorry. Y equals x squared plus 8x minus 4. Shrink that little baby down just so we can see it. It's what it should look like, right? It's a square, so it's going to be a parabola because it's a quadratic. It's a positive a, so we know it's going to open up. And the other one was 2x squared plus 5x minus 8, right? And kind of zoom in on your little guy, right? Where is it intersecting? Oop, it's intersecting right there at that point. Might have to... And we're going to go at that point, right? So that's one way you can solve it if you wanted to use the graph. And then the second way would be using algebra, right? So in algebra, because we have y equals and y equals, what do we know about these two equations? They are, they're equal to each other. Yep. So we can set them equal to each other. X squared plus 8x minus 4 equals, whoops, there's a 2 there, sorry. 2x squared plus 5x minus 8. All right. If we're solving quadratics, we want to get everything on the same side. So I always make it to where my a is positive. So I'm going to move everything over to the right. So I'm going to subtract x squared. So 2x squared minus x squared is going to give me x squared. I'm going to subtract 8x. So I'm going to get negative 3x. I'm going to add 4. So if I add 4, I'm going to get negative 4. And that guy still equals 0. Squeeze this up a little bit for you guys just to see it. So then now you can either use the area model, or you can try and jump right to factoring it. So we got an x and an x. When we multiply a times c, we get a negative. So one's got to be positive, one's got to be negative. Right? A times c gives me the 4. So it's either got to be 1 times 4 or 2 times 2. But I got to get to a 3. So I know it's got to be the 1 and the 4. And since it's a negative 3, I know it's going to be a negative 4 and a positive 1. Right? 0 product property tells me I got to set those guys equal to 0. So you get x plus 1 equals 0, x minus 4 equals 0. So x equals negative 1 and x equals 4. So that gives me the 2 x coordinates. So if I'm looking for where lines or where functions intersect, they intersect at a, starts with a P, a point, right? And a point is made up of what kind of coordinates? An x and a y. Yep, good job. So we have the x, so we got to find the y. How are we going to find the y?
Put that back into the equation.
Yeah, does it matter which equation I pick? No, because it's where they intersect, and when they intersect, that x and y are going to be the same, right? So it doesn't matter which equation you pick. So you pick. You want the top one or you want the bottom one?
Doesn't matter which x you pick.
You got to do both. Because remember how it intersected twice? So there's 2 solutions. Yep.
Okay, so you got x plus 1 and x minus 4 by multiplying?
Your factors right here, right? They're being multiplied. Yep. And those, when you multiply, it's got to equal 0. So the only thing you can multiply something by to get it to equal 0 is it has to be a 0, right? So that means either this has got to equal 0 or this one's got to equal 0. Yep, that 0 product property, right? Anybody plug it in and come up with anything? Oh, if I did the top one and I did my negative one, I'd get what? 1 minus 8 minus 4. So that's going to give me what? Negative 11? Maybe, right? So that was the point when x was negative 1, y was 11, right? And then you got to do it for 4. I'm just going to use the same one. 4 squared is 16. 8 times 4 is 32 minus 4. What do we get for that one? 40? Yep. So when x was 4, y was 40. And then those are your 2 solutions. Not too shabs. So all 3 of those main little topics, those little math notes, are in that section, in that 4-2 section. So in your notes, like, it's a good part to kind of go through and write these down, or at least have those examples written down so you can kind of refer back to it a little bit. All right. So you guys got one last task to talk about today. Is this little guy. So I put you guys all, I put the whole school, or all of our like Algebra 2 classes, we're all in this little competition. And in the competition, we're tied for first right now. So you guys, I mean, this is the deciding factor. The judges decided to come up with this little graph. And you need to come up with 5 questions to ask about these graphs, and then be able to give an answer, to those. And like, they got to be math related. You can't be like, hey, what color would you color the triangle? Right? They got to be math related. So we just need to come up with, or you guys need to come up with like 5 questions that you would ask about a graph like this. And don't forget, this is a competition. And then come up with some answers.